Welcome, everyone. Big welcome to the Tezos hands-on dApp training workshop run by Marigold. Big welcome to Ben from the Marigold team, and a big welcome to all of you. Great to have everyone here. Thank you for joining us from all around the world. I've had a couple, I'll say 2 days full of calls with all the hackers from Tezos. It's been a delight learning about what you're building, understanding, kind of maybe giving some advice as well. So please, if you haven't booked a call with me yet, please do that. I really do enjoy talking to all the hackers and understanding kind of the general feel of the hackathon. Every hackathon's got a kind of a different feel to it. Just some general things before I hand over to Ben. If you're not on the Discord already, please join the Encode Discord. I've just sent it in there. And please join the Tezos Discord as well. Kind of just all information is going through there. And if you're missing out on anything, that's potentially why. Obviously, there's quite a few different communication streams, but number one would be to get on the Discord, especially the Encode Discord, and then we'll either direct you to the Tezos Discord if there's some technical questions that need to be answered. This event will be recorded and added onto YouTube tomorrow morning, first thing. So I'm UK, so tomorrow morning, maybe night for some of you. And other than that, I'll be on links. I'll send a couple of links in the side, just some general information throughout the event. And Ben has asked if you could please save your questions till he's done with his presentation, just so he can get through everything, and then he'll answer all the questions that need answering. If you can, please switch your cameras on. I'm sure Ben would love to see kind of all your faces while he's teaching you. Ben, absolute privilege to have you on. Over to you.
Thank you. I have not a lot of time to do all the full training, so I will be a bit fast at the beginning. But I want you first to explain you some of the details of Tezos on a short presentation first. Then we come to the training, and then I will take the answers at the end. So I don't know the level of the people here, but it really start basic the training for everyone. Let's share my screen. I will start with some presentation first. Okay, so I'll start with a short presentation on Tezos, who I am. So I'm tech lead at Marigold, and I'm doing the apps and training for Marigold. What is Tezos? So I don't know, people here, they know already. So it's decentralized open source blockchain, peer-to-peer transaction. What's important, it has a native cryptocurrency inside of the network itself, named Tez. XTZ is a symbol. It has proof of stake consensus that is eco-friendly. On-chain governance model that is quite unique on the market. About the networks running, you have one public network called the mainnet, and you have several additional testnets. So you have Granada, Angzunet. Now you have Ithaca, that is a new testnet that has been released to the mainnet now, and the next one is Jakarta Net that has been announced a few weeks ago. So you can run some passive node or node validators. They are called the bakers. It can be something relative to what they call the miners in the blockchains. And what is also nice to see is if you are not a baker, you don't want to participate to the network, you're just a simple user of the network, you have an account there, you can also delegate your thesis to the bakers, and then you receive some rewards. It's called delegation. You don't have, as a public blockchain, you don't have a certificate authority on the network. The consensus, so it changed recently with the last release from EMI Star to Tenderbake. So it's a proof of stake consensus. The new one is as a deterministic finality that use two phase of endorsement that is a bit different to the first one, that more an optimistic termination. You still have a unique elected baker that is executing a transaction at each new block. That's something that would be different to other blockchains. So it means that you don't have really multiple execution, no parallel issue, as you have only one baker that is forging the block and not several that are trying to execute the transaction. So the execution is sandboxed. So you cannot, from the inside of the smart contract on chain, you cannot call the outside world. So this is also something to take into account. So if you want to call an API, for example, outside, I will talk a little bit about how you can do that. But you have to think about everything is sandboxed on the smart contract. It requires Oracle, of course, as the solution. The language that is in the base of the Tezos blockchain is called Michelson, and is a low-level stack language. So it's not really user developer friendly. We recommend you to use other high-level language like LIGO. So you have different version of LIGO, like the JavaScript version, Pascal version, Camel, and Reason. You have to be careful also on some specificities like getting the current date. If you want to do a date not now, for example, this kind of thing. It's not really the time or when you're thinking is date now of the server. When you are executing that, it will be the timestamp on the block where your transaction will be part of. About smart contracts, so the read operation are free. There is no cost to read the storage. For write operation, they are quite cheap, some cents. You can call other contract from your smart contract. So you have inter-contract calls. You have to use some callbacks. Each contract has a balance. So you have to see that you have accounts on Tezos, and you have what they are called implicit accounts. They are user accounts, like user accounts you have in a wallet, and you have the contracts. But the contracts themselves, they have also an account, and they can have a balance. So you can send tokens, or you can send thesis to a contract, and it increase the balance of the contract. It's important because you can do a lot of manipulation like this, for payments, as an example. You have fungible and non-fungible tokens, like in Ethereum with ERC20, ERC 721. You have a way to attach metadata also to a contract, and you have some formalization, verification via other tools. Okay, so let's talk about limitation and solutions. You have slow transaction per second speed, but still better than other public blockchain. So it's, of course, it's slower. Every blockchain is slower than a regular application on the cloud, for example, because it requires encryption, etc., and synchronization. So you have on the layer 1, you have a speed that cannot increase too much, but you have other solution called layer 2, where you can validate the transaction in either a sidechain or another let's say execution context, where you can submit some proof on the layer 1. That's called rollups. I will not go too in detail about that, but you can increase a lot the speed using layer 2 solutions. You have also limited storage size and a quick exponential cost on that if you want to store a lot of data on it. So the storage, you have to think about when you are in a smart contract, the storage, of course, is limited in size, but also it costs a lot of money because it takes some fees. So it's you have an estimation of the cost of the storage before you run a transaction. So you have to pay the storage in some way to the people maintaining the network. So the advice is to store only what is really useful for your smart contract to run. So any extra information like media or very large text, they are not necessary like a description, for example. We are called that metadata. You should never store that inside of the storage of the smart contract. Also, but there are what they call the RPC nodes is Tezos node. The API is a bit low level, and sometimes you don't have a lot of caching, or you're gonna do some join requests between the different endpoints. So you can use indexers. I will talk about that a bit later. And natively, you don't have events. So when you're executing something, the smart contract by default do not emit any events for the moment. It will come in the next release natively, so you can use an indexer. About the architecture of a decentralized application, let's have a look about one typical application. So the app here is described by a client application on the browser, and you can use Taquito SDK, that is a wallet SDK, for example, written in TypeScript, to build your client app. So it could be whatever framework you like, Angular or React application, and then you embed the library of Taquito, for example, and you use it to interact with the wallet of the user. You have the Tezos network in the middle. With a smart contract you have deployed previously, or even you can deploy it from the client application also, it's possible. You could have some Oracle. I will describe what it's for. That is also a smart contract. You can use IPFS or another cloud storage for storing your metadata or media data. And on the bottom, you can also leverage an indexer if you want to have some joins between objects. They are in fact part of the RPC node, but they're not easy to retrieve and cost a lot of time. So we'll describe a bit later each part. So about the indexer, so the Tezos RPC node does not provide indexes. So give an example. If you have to query 10 times a node to get the last 10 transaction, that's quite costly. So you can maybe have an indexer, and then you set in parameters that you would have to get the last 10 transactions, and we have that in one call. So it saves you 10 times to call the RPC node. If you want to do some joins, like for example, get all the contracts from a particular user, then the indexer has natively inside relational database. So in one call, it does the joint in the relational database and return back the results. If you don't do this with an indexer with the RPC node, you have to scan all the blocks to find all the deployed contracts from a user. That is quite expensive. So about the Oracle, the problem is a smart contract execution is sandboxed, like I said before. So if you want to call an API from the outside, you cannot do that. So the solution is that you have an external system, for example, a scheduler, for example, that is fetching some data somewhere, and then is pushing regularly data inside of the Oracle storage. Then this data inside the Oracle storage is up to date all the time. So another smart contract can do a call to this Oracle other smart contract to look at the storage and retrieve this information. About the metadata, so like I said, you can store huge amount of data and it gets quite expensive if you want to try to do so. So you rapidly stop to do that. So you can store this data off-chain, so in IPFS or another cloud storage. And what you do is you store the links in the smart contract. You store the links that can be also fetched after by the your client app to retrieve the images, pictures, the media, the movies, etc. It is the way that NFTs they do this. About the ecosystem, so maybe most of the websites on the Tezos ecosystem, TZKT for is a blockchain explorer, and you have the indexer also. You have TZStats that gives some statistics on the network. If you have some aggregation data. You have Tezos Agora Forum. Is more on the amendment of Tezos if you want to follow the updates of the protocol itself. You have the website of LIGO with a playground where you can an ID online and you can compile and deploy your smart contracts directly from the website. And of course, Taquito that I talked before to help with wallet SDK. Okay, do you have some question first about the presentation, and then I pass to the training? Okay, so I will pass to the training section. So here is the link. I don't know if I can. Transaction per second. How slow it is? Well, it's quite hard to answer, in fact, because there is a size of blocks of a block, and after you have in this size you can pass transactions, and depends on the size of your transaction also. So you can have maybe one transaction that takes all the block, this is big, and you can have a very small transaction, and then you increase the transaction per second. So I would say that transaction per second is not very accurate to see what is the speed of the network. It's more the size of the block that is more talkative. So I don't have the numbers right now in front of me. So I can search for that after if you want interested to know, but you can have an average of transaction more than a specific number.
Can we use Chainlink as an oracle? There we go. I don't think Chainlink is on Tezos, so probably not.
It seems to be on Ethereum, what it says here. So I don't know if they have done something for. It seems that they have something here, collaboration. There's a partnership, yeah. Maybe they have deployed their own oracle. So it depends what they provide. I know there are some oracles, they are available on all the networks and even the testnet, and they provide some financial data. So Chainlink or others, whatever, they can push their own oracle into Tezos. It's totally open. After you have to trust the oracle. That's the only thing.
Okay, perfect. Thanks. I think we'll you can carry on with your presentation, and then we'll save the questions for the end so you get through everything.
Okay, thanks. Okay, how do I know? Okay. So the training is very basic use case, a bit stupid, but the goal is to be as simple as possible as first training to Tezos. The goal is to create a smart contract. So in JavaScript Ligo, deploy the smart contract to the Tezos. So I think by default I did it on Encode, but you can do it on Itaka net. It's not a problem. The testnet, they are free of use, so there is no trouble of spending money because they are all free. Then you create the dApp that is the client side, and you're trying to interact with the smart contract that you deployed, and you're using also your browser wallet like Temple, and also if there is a use on Netzer for some requests. So the game is stupid. Is you have a user that has a browser application. It's trying to poke a smart contract, and then what we do, we store the poke in the trace in the storage of the smart contract. And then with client app, we are able to see how it's moving. So on the prerequisite, you need to install a text editor. You're not obliged to use VS Code, but up to you to use your editor you like. We will need to use npm because it's a React application, so not JS app, and Yarn to compile, but you're not obliged to use Yarn. We will use Ligo also, Ligo. So we need to install it. Tezos client. So you have two ways to install the client, and Temple wallet. So, or you install all the software on your machine. I don't know which kind of machine you have, or you have an alternative to use Gitpod that will span an environment for you with Ligo that is pre-installed with Tezos client. So this can take several minutes to install all the stuff here, depending on your past experience with Tezos. Once you have installed everything, when you create a project or you go to a specific folder, and then you can start with creating the directories. I can add something in training. Okay, good. So if you want to, you can clone also the repo. So the solution is on the folder solution. So look at it if you have any problem. The doc folder, don't care about it. It's just to have the picture that you have after to be displayed on the documentation. That's the documentation. This is a solution with all the code. So you have two folders on your project. One for the smart contract, one for the dApp that is the client side, the React app. So just ping me when you have finished to install the prerequisite, because it can take some time for some people. I haven't put the versions of the software here, but take the last versions. VS Code is okay, npm is okay. Ligo, you have a version is 0.40. Tezos client, I think the last version is, let me check that. Yeah, of course, yes. It's really an introduction to Tezos development, smart contract, and the apps. So if you are new, it's a good session, the training number 1. I'm doing other training. Haven't finished the number 2. It's going more and more complex all the time. So this is the first one. As you see, the sequence diagram is quite easy. It's just a call to a transaction. So yeah. If you are really new, it's really good to start with this training first. What you will require is it's a beginner session. So coding is mainly on JavaScript, JavaScript or JavaScript-like. JSligo is JavaScript-like because it's not 100% JavaScript. That is really close, really close. So if you know JavaScript, it's okay. If you don't know, just copy paste, try to understand the code. Like I said, here is not also a training for HTML or React training. So we will use React and HTML for the dApps and the client side. I try to be as simple as possible in React to not complexify the things. So you will see that at the end, the application is quite ugly, but the goal is to not spend time on React. So what is React? It's a good question. So React is a framework. So I use the TypeScript version. It's a web framework, I would say. So if people, some of you knows Angular, it's very close to Angular in the way they are doing things. Why use React is because it's quite popular framework first, and secondly, it uses TypeScript and Taquito library. Use TypeScript it's written in TypeScript, so very easy to import the libraries. So there are two big sections in this training. Oh, first part is a smart contract. So you can see that as the backend of your application in a way. And the second section is called dApp, that is a client side. Because the dApp normally is the complete solution. So the dApp is including the client side plus the smart contract, in fact. So here is the React part. So if I take the code here, so if you have a look on the solution, so you see that the solution has two folders. So you will start with a smart contract, that is JSligo code. So you see there is not a lot of code, but it's important to get the meaning of all the parts, main entry point, etc. And then after you do the second part, that is the app, is a React application, and you have the web app. So let's explain this. What's Yarn? Yarn, good. So Yarn is another, I would say, it's a bit like it's based on NPM. It's a package manager for JavaScript libraries. So it's a bit like NPM. NPM is also a package manager for JavaScript libraries. I use Yarn because it resolves better the dependencies than NPM, but it's not mandatory to use Yarn when you're doing JavaScript development. And here it does not really complexify a lot of the solution. So I will try to describe the steps. So let's start with the smart contract. So what you do, I don't know if you are used with, so it's all written in a Unix way. So if you have a Mac or a Linux, it's quite easy. If you have a Windows machine, I don't have this within PowerShell here, but try to make the same. So make here is to create a folder. So create a folder named smart contract on your project, and then touch to create a file. So here also you can use your editor if you want to create a file. So here to create a folder, here to create a file. So you start with creating the smart contract file named pokeGame.jsligo. Yes, like I said, in this tutorial, we are not going to use dedicated backend. We are going to use the smart contract as the only backend and the indexer as a helper, if you want, backend helper to help us retrieve some data faster than calling the RPC node. So standard, what you call validation cost is to validate the input parameters. What you mean? So yeah, for coordinates, so you have two choices. You can do the validation in the client side. That's possible. So before you send that to the backend, then you validate on the client side. Or you have to call the pre-validation and then a specific backend in between you and the smart contract to send the transaction. But if you do that, well, you can always call the endpoint anyway, because when you send the transaction, you need to know where is the smart contract endpoint. So anyone can call the smart contract entry point. So if you don't check the geo coordinates, and you do on the client side or through an intermediary backend, you cannot prevent anyone for calling directly the smart contract endpoint, and then maybe your smart contract endpoint will fail. So it's always recommended to have the verification anyway on the smart contract to avoid, for example, a hack or whatever. Can we get free tests on the testnet? Yes, of course, it's free. You can get from the faucet. We will see that in the second part with the dApp. We will have a link to the faucet here. Here we import the keys and use the faucet. So here is the link. You can get free tests here. We will see that a bit later. At the beginning, we will not need to have thesis because we will use JSligo and deploying it will be free on the testnet. So no specific gas. So yeah, you can originate contracts on the testnet for free, and then we will pass transaction. We will use the faucet to get some free tests on the testnet on the second part. Okay. Okay. So once you create your folder and your file, then you will try to write the main function. So you always have a main function in each smart contract in JSligo or whatever. So you can change the name, but I discourage you to change the name of the main function, but you can do it. It's possible. And the main function has always the same return type. So here I know if you are used with the syntax, but it's kind of looks like a lot of TypeScript. So the return type is always the same, is a list of operation. So operation is an execution of a line of code if you want. It's a keyword. So you have a list of operation and a storage, and this means that it's a pair. So it needs to have two elements always. The storage by default is unit. Unit means void or whatever is the same. So here in this example, we don't have for the moment anything, just you say with unit. And the list of operation, so it's a type definition here, is you're saying if you want the class or the definition of the objects here. And so that's the return type, that is mandatory. Then you have the parameters of the function. So you will is the same. The signature is mandatory also. You have so this is the type definition, and this is the parameters. So action is type of parameter. You have to read it like this, and store is a type of storage. And it's a bit different like this. I said it's JavaScript-like because in JavaScript or in TypeScript, better in TypeScript, you can, like I said here in this note, You can do it in a row like this, or in Java, or people do Java. Oh, the layout com is a bit more advanced. So don't worry with JavaScript like you declare in pair, like it is here. So action is of type parameter, and parameter is in fact the function you will call. So you have to see it's kind of a dispatch function. So there is someone that can do that is doing some noise. Can you be mute, please? So what you do here is a switch. So in LIGO, a switch is called match. So here we have only one case for action. So we look at the entry point for the main function that is poke. And if we have several, we can have a list here of different entry points. So the parameter means I call the smart contract and I want to call the function that is poke. So here you said if you call the parameter for poke, you have to call this function poke with the storage. So parameter is here, the definition of parameters. We have only one function that is available, is poke in the string. Okay, like I said here, match is a switch. And this kind of structure syntax is called a variant. We have some, the storage, good question, the storage. The storage is the database, the state of your smart contract. Maybe I should have a description first. So when you deploy a smart contract, you have some code, and also you have the storage that is relative to the smart contract. And there is a segregation, of course. Your smart contract has its own storage. You cannot share the state of your smart contract with another state. Okay, they are all separated. And the way to communication between the smart contract is called interaction. You have to do in inter calls between the smart contract. We will not see that in the training one. That will be for the training two. So smart contract calling was a smart contract. Like this, you can access the state. There are other ways also we'll see in the training two to get that. But you have to see that storage is a state. Or like the database if you want. Okay, so like this, you cannot store anything because here it says storage is unit, it's kind of void. And the poke, for example, we haven't written poke. Okay, once you have understood this, so here you start with the definition. So it's a type definition. Here is the main function. Then we'll try to write the poke function. So write the poke function. So now we change the storage to a set of addresses. So what we record here is all the addresses of the callers. So if we come back here, we are here. People, they are calling the smart contract. Every time someone is calling the smart contract with poke, we register the address of the account of the user that is doing this thing in a kind of a trace in the storage. Okay, so we have to pass the store as parameter. Please, yeah, thank you. So we have to pass the storage as parameter to the function because we will update the storage. And from the main, you have this function. So the library, Tezos library, dot source, here inside you have the address of the user that is calling as a smart contract. So what you do, you add the address of the user that is calling the smart contract in this transaction to the store. And the store is a set of addresses. So you just add people who are poking. So you have access to the set library. So here you have the documentation of the set library. So set.add is adding an element to the set. And you have some specific function here for the Tezos library. You have also the link. Okay, that's done for the code itself. So it's quite simple and straightforward. That's the full code here in the solution you have. So, okay, once the code is done, you can try to compile it. So if you have installed LIGO, then you do LIGO compile contract. Then you point to the path of your smart contract file. And then you can pass on extra parameter to transpile it to Michelson code. So like I said before, compiling is taking a LIGO file and is producing a Michelson code, because what will be deployed at the end to Tezos will be Michelson code. So it's .tz is Michelson code. So it's the low-level stack language I talked before. So do it like this. Like this, we will use it after to deploy the smart contract. Also, well, everything in fact that will be deployed, so the code of the smart contract or the parameters that will be passed to the smart contract or the storage, if you want to have an initial storage, everything that you interact with Tezos node has to be Michelson. So you have to compile, for example, here the storage to say that when you are deploying your smart contract, you want the storage to be initialized to an empty set, for example, because we decide that our storage is a set of addresses. So when you deploy your contract, you say my storage has to be an empty set of addresses. So this also has to be compiled and is translated into a Michelson code. So here is the code of the smart contract, and here is the code of the storage that will be used for the initiation of the smart contract. Next step, you do a LIGO run, dry run. So dry run will simulate a deployment. You are not hitting really Tezos network, but it's kind of in memory if you want network for testing. So what you said that you want to use the code of the JSLIGO. The first parameter is a parameter of the main function. So by default, it's using the main function, like I said, so I don't have to set what is the entry point here. We will use the main function. So here is a parameter poke with empty parameter. So if you look at the main function, is this parameter that you have here. So it's a string poke, and here there is nothing after, so it means there are no extra parameters. So it's just a string poke to say I want to call poke. So you say I want to call poke with no extra parameters, and here is initialization of the storage. So before, when I do that for the Michelson, it will be a real deployment. I will use this file for real deployment on the Tezos network later. when I do a LIGO run, dry run, I simulate that I'm deploying that. So I don't need to use the Michelson. I just use JSligo code and syntax, and it simulates that first before deploying. It should work fine. So if you do this, the output says that the list of operation is empty, so there is nothing to execute, and the storage is adding I would say the random address of this test. So the test, if you do LIGO run dry run, is using a kind of random account to run the transaction. So here is the random account that is running the transaction. So he's adding the user address inside of an empty set. Okay, is what we want. That's really the result here. If this execution success, what we want is the POC function is adding the address of the caller into an empty set. That is good. That is sequence flow. Okay, so this is everything for the LIGO environment. So now you can try to deploy it on a real testnet. So once you install Tezos client, you can force to be on the Encode network, for example, or Itacanet if you want to use Itacanet. So here you say that you want to connect to a specific network that is a testnet for one. Then what you need to do to get this time real thesis from the testnet. So you use the link here. Why can't we use SmartP instead of LIGO? Compile LIGO SmartP. You can use SmartPy instead of LIGO. It's a Python way of writing the code. Up to you. So use a faucet. They remove it already. Now very fast. Nice, they remove it. So use the Itaka. Wow, they have been fast to remove it. So use the Itaka. I need to update my what they removed just last week. Yeah, so just replace Encode by Itacanet and it should be fine. There is no huge difference between the two. So it's just the dotted point that change. The name of the network in the dApp, I will need to update it. RPC0. Okay. There are different ones on internet. The one hosted by Marigold, the ECAD Labs, they have their own also. There are a lot on internet. If you search, I can have a look on Testnet, Tezos, URLs. I think is Takito has these things on. Yeah, you have this page. So you have still for Hangzhou, etc. But for the full set, I don't know what they removed it last week. Okay. So you have a lot of links here you can use. Use the one you want. It doesn't change anything. It's still the same network. So you have to take the Itacanet because if you want to use a full set now, there's no more for Hangzhou. So the poke is just an entry point for your function. So you can have different ways of calling your smart contract. So the main is the general entry point. So there is always a main. But in fact, when you have an application, you have several endpoints. You're not always calling the main. So main is a kind of a dispatch function that does nothing else than dispatching to another function. So when you pass to the main, then you have to pass the parameter saying the function you want to call. So where I am here, take the code. So when you pass here, action is what I have to call after. So here I only have one choice, but in the next sections of the training, you will see how to call other functions. So here is the string, and once it's matching this string, is calling the function poke. That is an internal function. So this is not exposed. What is exposed is the parameter that is a variant. Yeah, we don't have the statistics of how many projects are deployed with Sligo. I don't have the statistics, and I saw somewhere passing they want to have more metadata on the smart contracts that are deployed like Zendu. They can see the statistics on which smart contract has been written with which tool. Yeah, we don't have statistics today. It has to be done on the origination time. At origination time, we can pass on extra parameters. Yeah, I would do that. We can do that right now. I will change everything. Let me check. We need to change the code itself. So first I change this. I think this I will update. It should be fine. Like I said, there are not a lot of changes between the two. Okay, for documentation, it's okay. After we have to search. Into where here. Let's see there. Why it's not coming? Maybe I need to update the version. I wrote the training before Ithaca was deployed, just before. So that's why they removed the faucet of Fangzhou. Also, we need to update that version of see, it doesn't see. So I need to update the version of Taquito, and it should be okay. So I will push that. So if I refresh, should be fine now. Okay. So you should be okay with Exunet. How can you add your PC Azure to a website? Advantage of using LIGO was SmartPy. Well, I cannot compare with SmartPy because I haven't used it, so it would be hard for me to give a feedback about SmartPy. And FlexTC I haven't used too, so I cannot talk about FlexTC. I think it's for having kind of local testnet, yeah, for developing on OCaml for the node. I think it's more for the node itself. If you want to test the node itself and be close to the OCaml code of the Tezos node. Yeah, like we have here, we are not using any local deployment. In the first, we use run, dry run. So it's kind of simulation. So you don't need to deploy local node. It's simulation of what should do your code. It's working pretty fine. On the second training that is not finished yet, we will have unit testing. It's another way of testing. It's much better for unit testing, because here is a simulation of using of a transaction. And here is a real deployment. Here is a real deployment of your code in the testnet. Here you are using the Docker version. So it's one way of installing LIGO is using the Docker. Okay, about the testnet deployment. So the endpoint has been actualized now to Ithacanet. So you will need to get the free test from the faucet. Then you create your a local account with the file of the faucet, and it will give you free test. If you list it, you will see on the list of the known addresses your account. Here you name it as you want. Some people they set faucet by default. You can name it one, whatever. And then you can use the Tezos client to see the balance. I think it's quite big when you get from the faucet, so it's enough. Largely enough to do anything, to do everything you want. So once you have configured the faucet and you have an account with some thesis, yeah, you can use the Explorer, right? Then you deploy the contract. So you use the Tezos client, and you call the parameter originate. Originate means deploy. I prefer deploy, but it's called originate. So you deploy your contract. Here is the name of your contract. So my contract, whatever. It has to be the name of your contract. Be alias you keep on your Tezos client. If you want to reuse it, you reuse it, because in fact it's quite hard to remember a big address. So you say you are transferring 0 Tez because you don't need to pay here anything from. So here is a account that is running the transaction. So it will use your account you have created before with a faucet. So this guy is the guy who is calling the deployment, the account of the user, and running. Just say that you want to run a smart contracts file by the one you have compiled before. This is the Michelson representation of your smart contract in a file. Here, you set init. Init is to set the initial storage. So if you remember, we wanted to say that the initial storage of the smart contract is an empty set of addresses. So here you just include the Michelson that needs to set up the initial storage. And here is an extra parameter that is mandatory to say that you want a maximum to use one. It will cost you at maximum 1 Tezos to deploy. Because if you don't say that, you will have a warning and it will stop you to say, okay, put a limit. Is to avoid, just to know, is to avoid if you have done a mistake. If you remember, you cannot deploy a lot of data into the network, because if it's too huge, it will cost you a lot of money, and sometimes it's too big, it will not pass. So if you did a mistake and you, for example, here you initiate with a storage that is really, really big and you did a mistake, and you don't pass this parameter, you will pay a lot of Tezos for a mistake. So here is kind of a preventive parameter saying that, okay, maximum has to be 1 Tez that will cost me to deploy that. Just for that. And then you will have a long stack trace, and at the end, it will give you the address of the contract that has been deployed. For example, here. If you should proc fine, you should have the address of the contract, that it will be associated with your alias here. So this contract name is with this address. And then you can test it. So here you can do like this, because your main function, by default, you will call the poke. You can say that you want to call the poke parameter, but there is only one parameter on your function. Remember, it's only one that is called poke. You don't need to do like in the dry run, saying that in the dry run you are saying that you want to poke. But as there is only one function, you don't need to pass anything. In fact, it will call the default parameter that you have. That's why it's working when you just call your smart contract. You're just calling it, and it will call the poke, in fact, because there is only one function. And then you can get also the content of the storage of your smart contract like this. Get construct storage for the name of your contract, and then it will display what you have inside. That's the same way of using the Explorer in Tezos Hackathon. Yeah. You can see that also on Tezos Hackathon, you can research for the name here, that is an address of your contract, and you can see also the storage is possible. So if I do like this, I think I deployed previously on Encode. So if I go to Tezos, so here I have to be careful to select the good one. So if they still have Encode, for example, here. So I switch to the right network, to this testnet. If I do like that, I can see here the storage. So here is a trace of all the people who call me. So they poke my contract, all these people. So you do like this, or you do it from the command line, and you can see the same. So that's us for the first section. So we are, I think, out of time. Jake, you are still here?
Of course, of course.
So like I said, yeah, in 1 hour it's a bit difficult to pass everything. Because yeah, I don't want to be also too fast, but there are people that are beginners, and it's good to be slow maybe for explaining them the smart contract. So the first section is done. That's a smart contract and the deployment of the smart contract. If the people they want to stay, we can continue with the second section. That is the last one. Is the client side that is interacting, the web app that is interacting with smart contract that is deployed. It's okay for you?
That's perfect. We're all good. We can stay on.
Okay. If the people they can also write in which section they are, if they are in the first, in the second one, in which step they are for the first or the second one, just to know if I go too fast or I can start with the second section.
Just put a 1 or a 2 in the chat, which section you're in, either section 1 or section 2, just so Ben knows. Thanks, Brian.
Good. Okay, good. Okay, what takes time normally is a prerequisite to install everything. Sometimes you can have some trouble. But after is, well, the code is very simple, and you have the correct the solution, so it should be okay. Okay, so I will start with the second part. That is the client-side app. So you create another folder. You can call it dApp. That's, I think, what I have here. Yeah. So that was the first section. The second section is a dApp, so is a React to the client side. So you can create yarn create React app is creating a React application, and I said that I want to use TypeScript as default language, and then you go in. Then next step, you need to add the libraries of Taquito. So you add the libraries of Taquito, and then you add the libraries of TZKT. So what you saw before is a website of TZKT, but they provide the library of the indexer that is behind that. You have to be careful if you are using the last version of React script. Just be careful because React, they are moving. If I look on my configuration, React script is version 5 for me. I don't know for you, depends on your machine. Sometimes it's taking the version 4. For version 4, you have nothing to do. All works fine. But for the last version like me, in version 5 dot something, you have to be a bit careful. And you have to follow this troubleshooting here. There are some problems with some libraries. So just have a look on that. You need to add some dev dependencies. So you have to do that. So you will see that if you don't do this, at one moment when we try to compile and to I think it's here when you compile the code here, then you will have a lot of warnings and the server will not start. So it's not here. Here you will deploy because there is no specific code, and then after it will fail, and giving you this warning of missing library, this kind of library here for verify, etc. So just do like it's written here, add these dev dependencies, add this on the config override.js that you see here. There. So I added, like they said in the fix, just adding the missing libraries. And after it should be okay with React 5, React script 5. Sorry. Oh, maybe I haven't saved this file. Yeah. Okay. Once you have installed the libraries, you have done the fix for React script version 5 something, then you can start the server. So we have to change my endpoint because do it now is Ithaca net. So here I'm changing the network configuration. So if I start my server, yeah, now I need to update the library. Nice. Okay, I think this Taquito is old. So let's see, because now we have changed to Itaca, so I need to upgrade Taquito. Maybe I think it is. I think maybe also the beacon library has to be updated. Let me try to update that too. Let's see if we let that. Okay, let me try again. Sounds a bit better. Okay, so see, I updated the libraries in live from Hangzhou to Ithaca. So nice. Okay, so I will push the new deploy for Ithaca. It has been upgraded. So new versions. Oh. So yeah, I was complaining here. You see, was not seeing that before, and now it exists because the last library were not up to date. Now I have Ithaca. Okay, back. Oh, so yeah, so your application is running on localhost. So this is a default. You should not have this. You just have the React logo on your version. So it just means that you have compiled with the library, with React and the libraries of Taquito and the indexer. So what you will do next is to create the connect and disconnect functions to connect to your wallet. So look at this file. So here on your source, this is a default file from React. This is a default application. Yes, it is normal. I think is because you just did that, and after you have to create the two missing components files. So that's normal. And after you create the files, it should be okay, because it's compiling all the time. You have a change, so you don't have the time to write the everything and on the first shot. So Yeah, first you copy paste and you replace the content of the app.tsx file. What you have inside, just React. So here you have some state declaration is for React to update your components, your web components. So I will not explain too much React. We don't have a lot of time. But here, what you do is you have the library for Tezos that now is Ithaca. So you have the node if you want. So you will use the node as an entry point for passing transaction, etc. You will use a wallet. I should have typed it, the wallet. You will use user address, user balance. We will display no display. Well, and you have this part, and in React, this part is a templating part. So it's an HTML that is templated. It means that it's basic HTML, and you have some annotations or attributes that are part of React. Here is just for styling. Okay, I don't care about styling, it's just CSS. And here you have two components. That's the part that is important. So you will create a component that is a connect button, and another component is a disconnect button. So we will connect to your wallet and disconnect from your wallet. And here is the display, just to say, hey, user address. So once you are connected here, you should have your user address. So this is your account ID if you want, the same. And your user balance, that is a number of these that you have on your account. So once you have done that kind of homepage update, then you create the two other components. They are TSX files too. So if you look here, I have these two files here. So you create these two files on the source folder, the same as app. So the connect wallet, so this one is the most complex one. So that's React stuff to pass is to call between components. It's to pass some agreement between components. So we'll not explain too much. Here is the content. If you go at the end, you always have a return. So this is the templating part, like I said. So the HTML part, you want to display a button. So you want a button, and when you click on this button, you're calling a function, connect wallet. And connect wallet is a function that is creating an object wallet, and it's calling the beacon wallet. So beacon wallet is a library that is behind Taquito to connect to your browser wallet. I will show you just after once the two are done, button connect and disconnect. So what you have to pass as parameter is to set the network, so it's Taka, the node of the URL of the node. So here is requesting the permission for you on your wallet to pass transactions. So it will pop you up something. I will show you after. Yeah, say accept, and then when you have accepted, you are able to get some information from your wallet. So you can get the user address, and you can get more, also the balance if you want, like this. So you set it on React, and you can also call get balance from user address, and you can get the balance, set the balance. So if I go there, I have my React application. So I should have these two buttons and this. I will refresh. Okay. So if I connect, so this is beacon library you saw behind. So to connect to your wallet, so here they are the browser wallets that you have installed. So for example, I have Temple wallet here I will use, but you can have other ones. This our heavy client, I would say. I use this one also, or this one for mobile, for example. They work on mobile. Also, I use air gap. It works too. The other ones I haven't tried so far. Galleon I had hard. It was not working like I wanted. Temple I will use. So when you click on that, you have a pop-up that is asking me to take an account. So here I see Taka, it's okay. I want to use I want to use this account from my wallet. So here is an extension Temple that you have installed at the beginning. So here is there are accounts I have imported, for example. Or you create your own and then you have to send some tests with the faucet, etc. Or you import it, for example, you have created one from a wallet before, you import it directly. You look on the steps they are in the tutorial, and you import it directly into Temple. You can do that. So you import, for example, the private key, and then you have it here in Temple. That's cool. So like I said, now I have my account here. So it's the same as it's here. So it's this guy, Dakar, and he's this guy, he's the same. And here is my my balance. So here you are connected with the wallet. It's kind of login, logout way mechanism, but you're not using any IDP provider or like Google or whatever. You are using Tezos way of logging with your own account that you create without IDP. That's good. That's the Web3. And then the disconnect function, well, it's easy to understand. Disconnect function is another button, and what it does is setting everything to null, and is removing all the accounts, etc., destroying the client of the wallet. And then if you click on that, it's refreshing, and then you are disconnected. After you can connect it again, etc. Okay, and connect it again. Okay, connect, disconnect is the first step. So, okay, you have connected, disconnected. Here is how I explain how you import your account from the faucet you have done before when you were doing a local deployment. So you can import it, add your private key here, import the account, and you can play with the account you used before in the first section. So yes, this kind of message you have means that you are logged, log in, log out. And then on step 3, so let me see. Could you please repeat how to resolve the Webpack issues? The Webpack issues, you have to look here. Fix here. You have to add missing libraries. So when you have the warning, it says that some libraries are missing. So you do yarn install and you add the missing libraries. And after on the override file, then you add it manually one by one that say that is missing. So you have crypto, stream, assert, etc. And yeah, sometimes you have other ones. Just look on your logs and seeing which library is missing. You just add it with yarn like this, and then you add it on the file and the list here, and it should be okay. Yeah, I see, Steven, thanks. So after is to list. Is a way to look at the storage. No, not yet. First is to look at all the smart contracts that look the same. So here we use an indexer. It means that every time you deploy the smart contract, it has a signature of smart contract. You have entry points with a kind of definition, storage with its own definition, etc. And an indexer is storing all this information in a cache. So he knows everything about the configuration of all the contracts they are deployed on the testnet. So what you can do is use the indexer library to list all the contracts that are similar to mine. So if you have deployed the same code as me, you're able to list all the contracts on the network that look the same as me. You have two functions, get similar and get same. You can look on the indexer to understand what is the difference. And what if you do that, what you do is to add this function, and then you add on the template part, on the HTML part, you add another section just after your HTML at the beginning. So at the end of the HTML section on the app is the same file, app.tsx. You just add this part that is a button to fetch, and after you display what you have fetched. So if you look at that, I have the button fetch. I will shut down this. Well, let me check if I have what I have here. Maybe I've changed something. I've broken maybe something. Oh, it's new. I know why. It's because I haven't deployed on Itacanet. That's clear. Just someone has deployed on Itacanet. How we do it? The smart contract, because I deploy on Encode, so it's normal that it's not finding it. So I need to deploy it manually. Okay, so how we do it? Doc solution, smart contract. So you have to do everything. Oh, we do need the knife. Yeah, you have one. Thanks. I will use this one. So if I look at my here, I have this one that was deployed on. Nice, copy paste doesn't work. Why is it not working? No. Copy paste not working. No, doesn't want me to paste it from. I cannot copy it. Unbelievable. No, doesn't want me to copy. Shit. Anything. If I copy to the same, no, cannot copy from the chat. Unbelievable. Okay, good. I can paste, but I cannot copy from the chat. It would be hard for me to do that. Okay, so I will try to deploy anyway. Thanks. Yeah, if I click, yeah, it should be better. Thanks. Now I click here. Thank you. Yes. Hop. So it has redeployed, and now it works. Thank you. So yeah, on the code, it was a contract on Encode. So now we are in Itacanet. So I needed a contract from Ithaca. So here the so one has an address from TZ2. So here all the people that deployed contract, I look the same as the one that everyone is using. So there are 3 people that have deployed contracts. So it's nice to see that it's very fast, as you see, using the indexer. If you have to do that, imagine on the mainnet that is very old, you have to parse all the blocks to know where the contracts look similar like you. Is impossible. So it's better to use a cache with an indexer. It's very, very fast. Like this, you can do this kind of thing. So in constant time, you get all the contracts that have the same hash as you, or have the same entry points and signature and storage signature as you want. So I use this, for example, for another application for where I deploying templates of voting contracts, and everyone is deploying his own contract through a web UI. So everyone is able to list the voting session of the others, and they can vote on the others. So you can do this kind of things. So okay, once you have listed the contracts, you can interact with or your own contract if you know the address, or the others. So here I see that some people, they poke other contracts already. We try to poke one. So if I click on poke, I see it's showing me Temple Wallet if I want to confirm the transaction. Check. And I haven't put a refresh, automatic refresh. So if you can fetch, oh, you're refreshing here. So I should be somewhere right here. So I have poked this contract. Like we said, we poke the contract, and I have my name, my account ID that is showing here in the storage of this contract. So I can do the same with here. I don't know who is this guy, but I will poke him too. I will say okay. And you see, it's quite fast, the transaction. So for a blockchain, I refresh it here, but it takes on the testnet, I think, less than 15 seconds for validation. Less than 15 seconds. So here is even faster. You see? So it depends on the activity on the network. So if you have a lot of people on network and a lot of transaction, then they are all to be bunched in a block. So if you don't pass this block, you have to wait for the next blocks, etc. And but then the layer one is quite reactive on the testnet because there is not a lot of activity. But on the mainnet, if you have a lot of activities, that's why we have layer two solution like before. If you have really a big batch of transaction need to pass, and the mainnet is saturated, it's better to go to the layer two to pass all your batch of operation. They are heavy, and then it will be faster than being on the layer one and cheaper. So it's very specificity of blockchain development. If I come back to the here, so poking. So here we were using poking. So it's calling your poke entry point. Be careful on this note. When you have only one function in your Spark contract, the Michelson code will not take the name of your function. It will write default. So here, when you call Taquito and you say poke, normally it should be poke here. I'm calling the method poke, like I said here. It will not work. It should work, but in fact, Michelson code that is deployed, saying that there is only one function, and I will rewrite it to default, in fact. So I have to be careful just a lot of times first time. But if you have several functions, of course, the poke function is working, and other function that you write is working. There is no problem. It's only with one function. And yes, the last step is to display all the people who are poking, because here just add the poke button, and here you show the people, like I have the full solution here. You show everyone that is poking. Okay, and at the end, do you have more questions? Or I know that the React part sometimes could be a bit hard to understand, but that's not the goal of the training. Goal was to show you how to write an industrial application, but very easy use case from the beginning to start with. the smart contract, the deployments of smart contract. Not yet, the unit testing will be on the next training if you want to see how to unit test a smart contract. And then how you get your free test, your account, interacting with your smart contract using the client, Tezos client, and then using an industrial application that is a React application, for example, here that you have here, that very basic HTML, but to have the login logout, it's the most important things. And once you are logging logout, you can pass transactions here, so you are interacting with your wallet here to say, hey, I want to do a transaction, and okay, accept, not accept, I see the gas cost, etc. And then I have a real application, like I can discuss kind of the backend, but this is the blockchain smart contract that is running. And I can display information about the storage. I can use an indexer to have a lot of meta information about the network itself, to find out the contracts, etc., etc. So you can do everything, almost everything here. I haven't talked about IPFS of the metadata around the smart contract, so the information that is not stored in the smart contract but outside, like media, images, etc. Here you have only useful information for your smart contract, only in the smart contract. And you have the indexer, and we haven't seen the Oracle. It will be on the next training, the Oracle, yeah. Do you have any question, or you're stuck on a specific step maybe, or it's time for question? Okay, so like I said, I will prepare, I don't know when I will finish that, but the second session that is more advanced sequence, I think in the next week, maybe I will finish that. To use unit testing in the next training. We have unit testing with LIGO. You have inter-contract calls, and after I haven't finished, but you will have also how to use views. I will explain what is views. And I will update the React app to reflect this enhanced pokeGame.
But are you just going to wait on the call a little bit longer if there's any more questions, or do you want to call it there, Ben? Completely up to you. Christian, yes, the recording will be available later to watch. It will be available most probably tomorrow once our kind of operations team has edited the video, and then they'll upload it on YouTube. We'll send it on the Discord. So if you're on the Discord, you'll get a link straight away. If not, just go on the Encode YouTube. Does anyone have any questions for Ben before we wrap it all up?
Okay, you're welcome. Just a question, Jake. Do we have another session that is expected for a second session of training? Because as you see, I'm preparing a second training number 2. I don't know, maybe next week, maybe I can present it if they really want to see more things like unit testing, etc.
We don't. I think currently we just have an ideation workshop next week. And then we also have a front-end workshop. But I'm sure I think Kitty is still on the call. We can maybe try and coordinate to have one more workshop with Marigold. But we'll have to, I think I'll have to just chat to Tezos, and then chat to Encode, and then hopefully we can coordinate something.
Yeah, let's figure out a date. I mean, we run long and we still have 160 people. So I'm assuming that a second one would get interest as well.
Definitely. I think I agree with you there completely. Yeah, so we can coordinate another date. I can't give you a date right now. I just need to check with the Encode team to see when we have an available time. Obviously, we have other events running on. But I'll ping them straight away, and we'll get back to you literally in probably by the end of tonight, hopefully.
Okay.
Yeah, but definitely, I think we definitely want to have another workshop. I think the more the better, especially if, as you said, 160 people still on the call. I think the more learning, the better. Yeah.
Okay. I tease you already what will be on the next training. So if you're interested to join the second one, will be more complex and If you have very simple use case, like just one smart contract, it's okay. But when getting more smart contracts, and if you have an Oracle, like I said before, because you have to call an API that is outside, then you will need the training number 2, because there is no other way to call an API from us on unique smart contract like this.
Okay, perfect. We'll make it happen then. Yeah. Well, let's call it there. I think it's been a fabulous workshop. Thank you so much, Ben, for being here. Kitty, thank you so much for being here from Tezos as well. And thank you to all the hackers that were here. Hopefully you learned a whole ton. If you have some more questions that are technical, ask them in the Discord, they'll be answered. If you've got any kind of general questions about the hackathon, yeah, just either ping me or book a call in my calendar. And we'll have a little chat about what to build and maybe the steps going forward. Yeah, so thank you, everyone. Really, really appreciate it. And enjoy the rest of your day, wherever that might be.
Thanks, everyone.
Thank you, everyone.
Cheers.
Have a great day. Bye-bye.
Bye.